look at example 3.45 here. So it says a small toy airplane is flying in the XY plane parallel to the ground. In a time interval of 0 to 11 seconds, its velocity as a function of time is given by this, in meters per second with time in seconds. At what value of t is the velocity of the plane perpendicular to the acceleration? Now, the reason this one fits in here is because we have to use the dot product concept, meaning that if velocity and acceleration are to be perpendicular like that, that means that if I take the dot product of velocity and acceleration, which isn't anything, by the way, I know I'm going to get 0. Because whenever I take a dot product of two perpendicular things, it has to equal 0. All right, so that means I'm going to need to take the dot product of these two functions. So I'm going to need an acceleration function. So I have 1.2 I hat plus negative 2 j hat. Now I just need to take my dot product, and since it's in component form, I'm going to use the component method. So I'm going to multiply the x's together. So I have 1.2 times 1.2t plus, multiply the y's together, I have negative 2 times 12 minus 2t. All of this has to equal 0 because I want them to be perpendicular. And now I can set this up and solve for t. So if I go ahead and do this quick here, I end up with 1.2t, 1.2 squared, I guess, t, minus 24 plus 4t. Combine my t's and solve. So what do we end up with? We end up with 1.2 squared plus 4 times t minus 24. So I have 24 divided by whatever 1.2 squared plus 4 is, will give me my t value, and it should come out to be 4.41 seconds. There you go.